Hi, listeners. My name is Teminda Popola. I will be presenting a project titled Flood Damage Analysis using the PostGIS Spatial database. By way of introduction, floods are among the most destructive natural hazards, especially in densely populated areas. In August 2017, Harris County experienced one of the most devastating flood events, if not the most devastating flood events. And it delivered a record rainfall and widespread flooding across Harris County, resulting in, damage to homes, infrastructure, and livelihoods. As you can see, the image right here, this is Hurricane Ivy making a landfall, off the coast, inland of Harris County. So this study is going to be, using data from 43 flood-affected housing sites to build a robust spatial database that identifies flood damage severity and patterns, based on rainfall amount, building age, building damage amount, and water depth to help, users support smarter risk mitigation strategies. Why is this project important? Again, flooding is one of the most damaging disasters. However, traditional flood models usually show where water goes, inundation extent, but they often do not tell us who is affected, how deep the water gets, or how much damage it causes. And this is what this project attempts to solve. The model developed here, attempts to bridge the gap using spatial queries and geospatial analysis to identify the flood-sensitive areas of Harris County. And by analyzing water depth, the amount of water that fell, the amount of rainfall that fell, the age of building, and the damage recorded, we can identify where floods happen and where they cause the most significant harm. Basically, the goal is to provide useful information that city planners, emergency responders, and insurance providers can act upon even before the next major flood. Hence, be able to protect people, protect homes, and safeguard neighborhoods. 5 key research questions have been developed to be able to, address these problem statements. For lack of time, I would not be able to go through them one by one, but we'll talk about them later on. But this is just a table for each, containing each of the research questions. Where are we studying? Harris County again, as been shown in figure 1. And the time scale we are looking at is August 24, spanning through this, September the 13th of 2017, when Hurricane Harvey, recorded rainfall and caused widespread flooding and major structural damage. Where did this source the data we are using from? So water depth data, building age, building damage amounts for the 43 flood sites were sourced from the National Flood Insurance Program, and the daily rainfall estimates were gotten from checks. And this is at the resolution of 0.05 degree. This is a final resolution that allows us to capture localized rainfall patterns in Harris County. So we developed a database, we designed the database and included the documentation, as you can see from the table here. But basically what this is saying is that The spatial database consists of a single main table whereby a final project folder called schema is created in PGAdmin, and the table stores raw data: latitude, longitude, rainfall, water depth, building age, damage amount, and it also stores calculated fields, precipitation, total precipitation from various observations. We also have maximum water depth. We have age group, the average damage within each age group. Then we have the damage to rainfall ratio. Then I want to quickly mention that an ERD, entity relationship diagram, was created, whereby we have a primary key, which is the object ID. But in this case, there is no foreign key because database is structured as a single self-contained table without relational joins to any other table. I just wanted to put that out there. Now we have the views and the circle. In other words, we created query codes for each of the research questions. And this query code is going to help us answer each of the research questions. One of the unique strengths of this project is the fact that the query codes are created alongside views, what we call dynamic views. What are dynamic views? Dynamic views basically are just they are dynamic entities that are linked to the back-end database, such that if there is any adjustment, any addition or deletion of data set from the back-end database, it should be automatically reflected. That's how the query has been created using the view entity. And this is very strong so that we can monitor, as events are changing, more data is being included, the query will be live and updated. And these are the query. Each of these box stands for each query, attempting to answer each research question. And you can see all of that here. Also, very briefly, these are the threshold definition for flood severity queries. We basically use the 75th percentile to define extremes, For example, the total precipitation, 241.59 millimeter. That's the top 25% to define extreme precipitation. And then the age group classification, we have 0 to 20, classified as new, 21 to 40, classified as moderate. Then we have the old and the very old. Result and discussion, very briefly. So what question are we answering first? Where are the flood sites with extreme water depth and extreme building damage? And as you can see from the map, we have shades of green and in different sizes for each bulbs, or if you like, call them dots. So results shows that 5 flood sites met the criteria based on the query that we developed. And these 5 flood sites happen to, fall around the low-lying areas. In other words, where you have the digital elevation models, to be lower. To put things in context, this is the digital elevation model that was created for this project. You can see the green parts of them is the higher digital elevation model, digital elevation numbers, and you have the lower digital elevation numbers here. As a matter of fact, from the middle, the central areas to the southern areas all have lower digital elevation numbers. Even the southern as low as negative. And that is very informative to what we're talking about. Now let's go to the second map. What question is the second map answering? We want to see, flood sites where total precipitation exceeds 241.59 millimeter. In other words, where is the hotspot of the extreme precipitation in Harris County? And as you can see from the shaded parts, which met the rainfall thresholds. These again are corresponding to the low-lying areas in the digital elevation model, like I showed you before. So this is the low-lying areas, and that corresponds to where you have the hotspot for extreme precipitation. And this confirms, that extreme rainfall concentrated in low elevation zones. We have where are the flood sites with both deep flood water and older buildings. What this is basically showing us is the fact that where in Harris County do we have old buildings that are affected by significant flood amounts. As you can see, 82 feet of flood depth corresponds to areas where you have aging households. In other words, 7 sites mark this query, and they are marked by large red circles on the map, indicating severe building damage in structurally older zones. The study confirms higher flood vulnerability in aging households. By way of implication, there may be a need to improve building rules or even change land use rules in these high-risk areas. And the fourth one is, the fourth map is answering the question, where are the flood sites with high building damage? As you can see here again, despite relatively low rainfall levels, 7 flood sites were identified as shown by large red circles. The largest of them is in the million, while the smallest of them is in the thousands. This points to drainage problems or local runoff concentrations rather than just rainfall. Imagine having high, effect of flooding, even when rainfall values is low. By implication, that emphasizes that structural resilience and site-specific exposure drive flood damage, not just rainfall amount. And this is the fifth query, where the question is, how many new buildings have experienced significant flooding? And when we run that query, we found out that there are no flood sites that met that criteria, and no query was the query returned 0 result. That is very informative, because again, that suggests that modern building codes and material may offer better protection. It also indicates that recent construction may be more flood resilient in Harris County. In other words, the new houses seems to have better building codes, seems to have, for example, the new houses may have been raised from the floor, and that will amount to the fact that flood effects will have less effect. Flooding will have less effect on such building, and that's one of the reasons why this query returned 0 result. In conclusion, we found out that sites with extreme water depth and high building damage were found mostly in central and southern Harris County. Extreme rainfall zones are clustered in areas with lower digital elevation numbers, which will of course intensify the risk of floods. We also found out that older structures were more vulnerable to deep flooding, while some high damage occurred, even under relatively low rainfall, highlighting the importance of drainage system. Notably, no newer buildings met extreme damage threshold, suggesting that updated building codes improve flood resilience. Overall, the spatial database approach effectively identified critical vulnerabilities, providing insight that support emergency response planning, infrastructure upgrades, and long-term resilience strategy. By way of recommendation, we recommend that users of this result should invest in critical infrastructure and stormwater, systems. They should enhance structural resilience through building retrofitting and code enforcement. because these measures are proving effective as newer constructions have demonstrated greater resistance to severe flood damage. And finally, municipal planners or users of these results should assess drainage efficiency at the neighborhood scale and implement property level mitigation strategies. These are the references used in the course of this work, and this is the appendix. This is the end of this project, the end of this presentation. Thank you for listening.